Good morning, students. Myself, Dr. S. Davamanidas, Associate Professor from the Department of Civil Engineering in a Premier Institute at Virudhunagar, Sethu Institute of Technology. So, in this semester, we are going to discuss about the structural dynamics, which is offered in second semester for ME Structural Engineering. So, before going to the main concepts of structural dynamics, we should know about some fundamental quantities, fundamental principles, and fundamental concepts of structural dynamics. So, with the knowledge of fundamental concepts in structural dynamics, it will be easier for us to learn the advanced or further concepts and problems in structural dynamics. So, for that, we will see the basics of structural dynamics, such as what is structural dynamics and what are all the importance of structural dynamics and what are the applications of structural dynamics. And after that, we can discuss about the opportunities for a structural engineer in the structural dynamics oriented field. So, the first introduction is the definition of a structural dynamics. So, generally, what is meant by structural dynamics? A structural dynamics is a study of the behavior of a structure with response to a dynamic loading. So, what is dynamic loading? A dynamic loading is a load which is act with respect to time, or all the time dependent loads are known as dynamic loading. So, when a structure is subjected to this kind of dynamic loading, then the behavior of the building or the structure will be different when compared to the action of static loading. So, the study of the behavior of a structure or the study of how the structure responds to a dynamic load is known as structural dynamics. So, for example, of dynamic loadings or wind loads, seismic loads, or vehicle loads, these loads comes under the category of dynamic loads. So, we see the basic definition for structural dynamics, and now we can see the importance of structural dynamics in structural engineering. Since the structural dynamics is a vast area, we limited the structural dynamics into structural engineering for the purpose of our course. So, in that, the importance of structural engineering are very useful, and it is vital for the modern structural engineers since they use the structural dynamics concept to design the bridges, buildings, or other structures for the purpose of ensuring that how much of earthquake loads or dynamic load is going to affect their building. So, with the proper knowledge of structural dynamics, we can ensure the amount of forces or the effect of dynamic forces that is going to be act on our structures. So these kind of effects of dynamic forces can be caused to a structure in the form of a seismic force, wind pressure, or a vibration from the machine, and a dynamic load from an automobiles or an locomotives. So the six main key point for importance of structural engineering in the case of structural dynamic is, first thing is we have to ensure the safety of the building. Second thing is we have to improve the seismic design, and third thing is we have to control the vibration, and we have to reduce the material usage. So like that we are having some key points of importance of structural dynamics in structural engineering. So when comes to ensuring the structural safety, so that engineer can use the structural dynamic analysis to prevent the catastrophic failures of a building. Since the dynamic loads are unexpected loads, due to unexpected conditions, a normal design or normal analysis would not help to prevent the catastrophic failure. But in case of a dynamic analysis, the system will be properly designed for the seismic forces, the wind forces, or any other unexpected dynamic forces. So, due to this proper design and analysis using structural dynamics, the building will be safer and the catastrophic failures will be prevented. The second case, when the building is capable of absorbing and dissipating energy, then the building will easily take care of the seismic forces. So, when we are constructing a building in the seismic prone zone, then we have to ensure that the building is quite flexible and it should have the capacity to absorb the energy and also to dissipate the energy. In that case, the building will maintain a sustained long term longevity. So, to improve this, we have to use a proper seismic design. By improved seismic design, we can definitely achieve the safety conditions for building under seismic zone. So, for this purpose, the structural dynamics is very important. And the third thing is vibration control. The vibration is a main scenario which is greatly affecting the structure. So the vibrations may be in the form of machines in industrial buildings, or due to wind loads subjected in the high-rise building. So it will create some oscillations. For that purpose, the high-rise building will subjected to vibrations, and in the industry they will use lot of machines. So all the machines will create lot of vibrations. So to maintain comfort and to improve the longevity of a structure, structural dynamics is very important. And with a strong knowledge and clean understanding in the structural dynamics or dynamic behavior of a structure, then we can easily build a structure with strong and full efficient, so that we can reduce the material cost of the building also. So whenever if we are strong in structural dynamics, then we can easily understand the behavior of a structure under dynamic loads. So when we have clear knowledge, then we will able to design a building with proper seismic design, and due to the proper seismic design, the building will be more efficient, which will in turn reduce the unnecessary material cost. And in the case of bridges, the long term durability and the reliability of the bridges and the transportation systems can be increased by having a good idea of structural dynamics. And the two main field which are the structural dynamics plays important role are aerospace and offshore structures. In the aerospace field, we are going to deal about dynamics only. So all the aircraft should be designed for dynamic loading, so that the structural dynamics plays a very important role in the aspects of designing aircraft, ships, and offshore platforms. So these kind of platforms will always or frequently facing the effect of dynamic forces. For example, when a ship is sailing in the sea, it will subjected to dynamic force in the form of wave force. At the same time, when an offshore structure is constructed in the middle of the sea, it is frequently subjected to dynamic forces due to wind and also the wave forces. So, while considering constructing an aircraft or offshore structures or ships, the dynamic analysis should be done and the proper structural dynamic knowledge is needed. So these are the importance of the structural dynamics in the field of structural engineering. Then we can see about the applications of structural dynamics. So the application of structural dynamics is very important in predicting the response of the seismic and wind loads by a structure. So, with proper structural dynamics, we can easily predict how the dynamic forces will impact the structure and we can design according to that. If we are constructing a construction in a normal place, then we can use normal design. But when we are constructing a construction in the seismic prone zone or the place which is located nearer to the fault region, then we have to consider the seismic design. So to make a seismic design, we should know what is structural dynamics. So when we know about structural dynamics, we can easily design a building for earthquake so that we can easily construct a earthquake resistant building. So for example, in the case of skyscrapers, they are built with tuned mass dampers. So what is the main purpose of tuned mass dampers? In skyscrapers, due to their height, it will subjected to heavy wind load. So due to these wind loads, the building will try to accelerate in the direction of wind. So to counteract these accelerations, a tuned mass damper are installed or incorporated in the high-rise buildings or skyscrapers to avoid the wind-induced oscillations. So they to make a building or high-rise building with tuned mass dampers, the knowledge of structural dynamics important, and the structural dynamics is very useful for these conditions. So secondly, in the case of vibration analysis of bridges and buildings and towers, the structural dynamics is applied. So the engineers use modal analysis to identify the natural frequency. Why? Because in at any case the natural frequency should not match with the exciting frequency or external forces, because when the natural frequency and the exciting frequency met each other, then there will be a resonance formed. Resonance means severe damage. So to avoid resonance, the natural frequency and the external forces or the exciting frequency should not match. So to maintain that, the structural dynamics is applied in the vibration analysis of bridges and buildings. Then to make a building earthquake resistance, the structural dynamics is applied. For example, the types of dampers, the amount of dampers can be determined by the knowledge in structural dynamics. So the building should also be flexible enough to reduce the seismic damage by controlled movement during the action of earthquake. So to make a building flexible and to install dampers such as viscous damper, friction damper and tuned mass dampers, the structural dynamics laws are applied. And to enhance the overall performance of the structure, base isolation technique is very important in case of stability. So in the base isolation systems, the elastomeric bearings or sliding bearings are installed in the structure, so which it will decouple the structure from the ground motion during the action of seismic forces. So the significantly, the base isolation technique will reduce the forces transmitted during the earthquake, and it will protect the superstructure. So in the field of structural health monitoring and retrofitting of existing structure, the structural dynamics laws are highly used using sensors and real-time monitoring systems. So the sensor and real-time monitoring systems are used to detect structural damage from earthquakes, wind and vibrations. So these are works under the principles of structural dynamics, and the structural dynamics is also applied in the retrofitting methods such as adding bracing systems or energy dissipation devices to help and strengthen the older structures. So, in all these cases, the application of structural dynamics is predominant. So, till now we have discussed about the definitions of structural dynamics, the importance of structural dynamics, and the application of structural dynamics. Next, we can see about the types of loading. So there are two types of loading. One is static loading and another is dynamic loading. So before going to see about dynamic loading, we will just have a glimpse about static loading. What is static loading? A static loading is a force that applied slowly and gradually to a structure. Whenever a load is applied gradually or slowly in the structure, then they are known as static loading. The nature and characteristics of the static loading will be they will have some constant magnitude, then there will be no changes or in the magnitude over a period of time, and the point of application of the load will be it remains same, and there will be no changes in the point of application, and also the acceleration is completely neglected since there will be no movement of the force. For example, uh, the weight of the buildings floor, wall and roofs, the weight of the furniture in a room, the force exerted by a parked vehicle on the bridge structures are some examples of static loading. When terms of dynamic loading, the load is caused by the force that are rapidly changing with the time. So simply saying a time dependent force is known as dynamic force, or time dependent loads are known as dynamic loading. The main characteristics of this dynamic loading are they will vary with the time. So the magnitude of the dynamic loading will be fluctuating and significantly varying with respect to time. And due to the variation in magnitude, there will be also changing in position also. The dynamic forces will not act at a single point of application. The point of application of the force will be shifted so that there will be no fixed position for the application of load, and due to the changing in position, then there will be a significant acceleration. The load rate of change is important and it will lead into acceleration effect. The examples of dynamic loadings are the force of wind gusset on a skyscraper, the weight of the vehicle moving across a bridge, the weight of the vehicle like cars, buses moving in the bridges can be taken as vehicle loads, and the seismic force caused during earthquake, and impact load from collision and explosion. And we discussed about what is static loading and dynamic loading. Now we can see the difference between static analysis and dynamic analysis. So the aspects such as nature of load, time consideration, inertial effect, equilibrium equation, application, and response types. These are the aspects. When we take the nature of load, the static analysis will have constant load, but in the case of dynamic analysis, it will be time dependent or time varying loads. When we consider the time, the static analysis will have no time dependency, but in the case of dynamic analysis, there will be time dependency. In the case of inertial effect, for a static analysis, it is neglected, but in the dynamic analysis, the inertial effects are considered. And based on the force equilibrium, the equilibrium equation can be solved in the static analysis, but the dynamic analysis, the equilibrium equation includes the inertia and damping force. Without inertia and damping force, it is not possible to make an equilibrium equation in dynamic analysis. And the applications are used for dead loads and wind loads. And dynamic analysis mainly used for earthquakes and vibrations. A response type is when the static analysis, the structure deforms until equilibrium is reached. But in the case of dynamic analysis, the structure accelerates over the time to time. And in the field of building design, bridge engineering, machine foundation, earthquake engineering, aerospace structures, what are the applications of static loading and dynamic loading? Let's see. In the building design, the static load is used for calculating the dead loads, live loads, wind loads under normal circumstance. But in the case of dynamic loading, it is used to design the structure against structural seismic loads and wind induced loads and impact loads. So, in the field of bridge engineering, the static loading helps to determine the effect of permanent load such as self-weight and vehicle loads only. In the case of dynamic loading, it analyzes the effect of moving vehicle, earthquakes, and aerodynamic forces to ensure the safety of the structure. In case of machine foundation, static load is not considered since all the machines are operates dynamically. But in the case of dynamic loading, the foundation for vibrating equipment should be designed properly to prevent the resonance. In case of earthquake engineering, the static loading is limited, but the dynamic loading is considered as primary method for analyzing and designing earthquake resistant structures. In the field of aerospace, static load is not much relevance, but the dynamic loads are used, or dynamic loads are used to study the vibrations and aerodynamic forces affecting the aircraft and spacecraft. So these are the applications of static loading and dynamic loading. And generally, in this class, we have seen about the definition of structural dynamics, the importance of structural dynamics, the application of structural dynamics, and what is meant by static loading, and what is meant by dynamic loading, and what are all the difference between static loading and dynamic loading, and then application of these two kinds of loads were discussed in this class. And addition to that, I want to share some information regarding the importance of structural dynamics in the various fields. So recently, one of the emerging field in the world is oil and gas. So these oil and gas extraction are happening in the mid of the sea. So to complete the oil extraction of oil and gas, today engineers are planning to construct offshore structures So the offshore structures are built in the sea, so it is subjected to dynamic force in the form of wave force. So when we have a greater knowledge in the structural dynamics, then you will have a good opportunity to excel your career in the field of oil and gas. So in this semester, we will discuss about structural dynamics in detail, and in upcoming class we will see about the single degree of freedom system. In that we will discuss about the vibration analysis for forced vibration system and free vibration systems, and we will also see about the equation for formulation, and after that we will see about 2 degree of freedom systems. So I'm eagerly waiting to have sharing of knowledge in the structural dynamics with you. Thank you very much. We can meet in next class. Thank you.